Fine. Let us attempt to reconstruct the slice. The pointer to the slice and the length of the slice is given to us. I feel this exercise may help us to visualize a typical scenario while interfacing with a foreign function. Let's fast forward a bit to assume two things. One, that we have completed the pattern counting functionality in Rust. Let us assume that. Assume. It's just a fast forwarding, right? Second, now your Python client wants to reuse this capability of counting a given pattern in a corpus of data for a data science project. So now how the scenario will be, the client can pass its requirements in the form of two arguments, the path of the file and the pattern it wants to search. But Python does not know anything about the slices and the strings. The same with if the client is Ruby or Node.js or C or Java. So hence it became a common tendency to favor a broker architecture or exposing this functionality as a web service that drives the conversation to happen through HTTP. So there are several architectural choices are in front of you, but especially exposing this as a web service, in my humble opinion, it is indeed a very complex and inefficient solution given the context. So we can offer an elegant and efficient solution to the situation. How? Rust has a great capability to offer a functionality through a dynamic library. That is what we are going to do after 1 or 2 episodes. So Rust can offer this functionality as a .dy lib of Mac or .dll of Windows or .so of Linux. So those are all the dynamic libraries, the extension of dynamic libraries. So a Python or Ruby or Node.js or C has the mechanics to load a dynamic library and invoke the functions using the great pointers. In fact, this is a traditional approach. So it is time to understand the strings and the slices from the standpoint of pointers. So we should be conversant in constructing a slice from the raw pointer and vice versa. So that is what this next 10 minutes we are going to discuss. In fact, reconstructing a slice from your pointer is just 2 lines of code, but we'll miss the mechanics involved here if you follow this route. Anyway, first we'll start with the simplest thing, that what Rust offers out of the box. Out of the box means they have all these things in platter. We are just going to eat that. And let us take this slice sentence and let us just change this slice text as Namaste. And there is the sentence itself, it is a string now, and we converted that into a S slice, which is a slice. So every slice, or whether it is a sentence or slice, we can just ask to this S slice. Let me call this, okay, S slice dot sptr. So this will give us a pointer to the first byte of the slice. So what does it mean? I have just created a visualization for you. If this is a slice 0 1, so that is we already saw that it is 18 bytes. Namaste is an 18 bytes, and the size in bytes is, if it is a U8 it is 1, so it is an 18 bytes length of 6 characters. And because we already found that each and every segment, that is each of these characters is made up of 3 bytes. And a string, we know that it is a collection of U8. And if it is an English character, each of them is a single U8. We call this as a single byte character. And Sanskrit and Tamil, for example, are 3-byte characters, and we have this representation here. So when you invoke this method as pointer on S slice, What it offers you is a star const u8. See that. So the first time when I saw this method, that is give me an s pointer star const u8, I was really confused. What is this star const u8 and why it should give us a star const u8? And let us go to this B slice. And when I invoke this this is giving me a star const I32. Now I understand to some extent, I could guess to some extent that being this vector or this B slice is a collection of I32, it makes sense that it is giving me a star const I32, and when I am invoking this S slice, which is a collection of U8, and this is giving me a star const U8. This is our slice altogether. So we took this namaste itself as a slice, and we know that a slice has a pointer, and where it is pointing to, ideally it should point to the first byte of this index. So what is happening inside this s pointer is, in fact, it is doing two operations. One is s slice as star const str. Fine. But we know that we cannot hold the str, but we can hold the pointer to this str. I have casted this slice into star const str, and then I will go and get again another pointer, which is a ptr of, I am again going to cast this again const u8. So this is what really happened when you are using directly this s slice dot s ptr. So the slice is cast into the str, and that str is again cast into a u8. Now I hope this makes sense. This entire thing is a slice. This is the str. So this, when I have to first cast this into the str counterpart, and later I have to cast it into the first byte. So in order to access the first byte, I have to cast that 2 times. So that's what is happening here. So if you put this in a single shot as const str and as const u8, this is what really a pointer is doing internally. So if you have if you want to check that, we'll first go to this as pointer method. See this definition. Yes. So as pointer of self, that is star const str. So the first typecasting is to going to the str. From the str, we are again cast it back to star const u8. So we cannot directly star const. We cannot use the star const u8 here. Is invalid. Casting ampersand str as star const u8 is invalid. So s slice as star const str and then as star const u8. So this is a pointer. This is what is really happening there as pointer. So if you apply the same theory here, how to get the pointer of this in case if an s pointer method is not there. So now you are getting star const I32, that is pointed to the first element of this V slice. So V slice, this is what a V slice is. So we have to first cast that into I32, that is an array, and then we have to get the first point, that is a pointer to the first element of this. So this will be something like V ptr1 is equal to V slice. It's just here, try S P32, and we cannot keep it here, it seems. This star const I32 Okay, and then I have to point to this I32. So again, what I can do is as const I32. So this is for what in fact the SPTR of our slice is, that is a, and which is a point, a wider pointer to an array or a contiguous memory. So there won't be directly a definition for this, I believe. uh, as const of this t as const of t, and now it is the t is 32. Now star const 32 as const 32. So this will again give you the first byte. Returns a raw pointer to the slice buffer. The caller must print. So there are a lot of other um, safety measures that we have to do, that have been provided here. So in order to do all this star const I32 and the star const 32, we normally have it as a practice to have it as pointer. So hope now you got some idea about how to convert a given string into a pointer. Either you just directly call this as pointer. There is ocean of information is available below the surface, and let us put this as PTR. Okay, now we got the PTR. Then once we have the PTR, what we can do is we can either travel through each of the elements this PTR using a pointer arithmetic, one after the other, and then finally we can convert it into an UTF-8, and rest again make your life easy by having a method in the std.slice from raw parts, and for which you can part this raw parts is a method, and to this method you can pass this raw pointer, this pointer, and along with the size, and the size now is s slice dot length, and this is the uh, function definition for this. You have to pass the data and the length in bytes, and what internally it is going to do, we will try to guess what it is doing internally in another 1 minute. So now we are getting a very interesting error. Now call to unsafe function is unsafe and requires unsafe function or a block. So why this is an unsafe function? Because whenever we are dealing with raw pointer and trying to convert that back into its original form, there is a possibility of an undefined behavior. So Rust is asking you to be aware of this and want to wrap this into an unsafe block. So whenever you are dealing with pointer and whenever you are dealing with situation that is beyond the boundary of um Rust, and if there is a potential of an undefined behavior, we will wrap that in this unsafe block. Now this raw parse is returning you an ampersand A of that type, that is ampersand, let us forget about this lifetime operator, ampersand U8. So let the constructed or reconstructed will be a ampersand, a slice of ampersand U8 or ampersand U8. So normally this is what we mean by a slice. So when you got a slice for this array, you are getting an ampersand I32. But as a special case for string, when we do an str, it is directly converting that into ampersand str, which is an UTF-8 representation. So now this, we cannot do anything with this U8, and we have to convert this back into an UTF-8 representation in order to complete the reconstruction. So that there is another method, and that will help us to convert this U8 into an UTF-8. And what is it method? And in the str from UTF-8, we can pass this slice ampersand UTF-8 to this, and what you let us pass this reconstructed, and let this is a reconstructed slide, and this is a result, because when we are there is no guarantee that the reconstructed slice of ampersand U8 can be converted into an UTF-8 representation. There can be errors because the characters needs to be a valid UTF-8 in order for it to convert this into an STR. Otherwise, it will throw an UTF-8 error. This is more of a result, not a reconstructed slice again. So let us use a reconstructed slice. If OK of reconstructed slice is equals result, that is, it will do an unwrap. If let OK of reconstructed slice, then either we can return that, or for the time being we will just print that. The reconstructed slice is an ampersand str now. Let me again show you that the reconstructed slice is an ampersand str. So this way, when a pointer is given to us, we can cast that 2 times, or we can directly use as pointer to get the pointer to the first byte of the slice, and then we can pass that method, the pointer to the method from raw parts along with the slice length, and then we can, which is unsafe, there can be a lot of unsafe situation or undefined behavior can happen. So Rust is asking you to place this inside unsafe, and we are getting a slice of U8, and the slice of U8 can be easily converted into an ampersand str, and using the from UTF-8 method, as again it is susceptible to errors because the members of this U8 should be a valid UTF-8 character, otherwise it will throw an error. So we are attempting to print this. Let us check whether it is printing the namaste again. Yes, the reconstructed slice is namaste. So this is what, in essence, when a Ruby client is offering you, or a Python client is offering you its parameter to search this term, it will pass you in the form of a pointer, and then you will construct from that pointer a ampersand str, which is a concept in the Rust terminology. Okay, so the pointer is a universal conversation medium here. Okay, now as PTR is doing a lot of friendly things for us, this from raw parts is doing a lot of friendly things for us. So being an engineer, we should not hesitate to open the engine to see what is really happening there. So we will try to do what this from raw parts is doing with a simple pointer arithmetic. Let us think for a while that there is no such from raw parts is available to us. So if there is a SPTR, then how we can get this ampersand U8. Okay, it's very simple. So there is one more method, that is what is available for every pointer is add. So it will be something like this: for I in 0 dot dot, we know what is the length of this. The length is very, very important, because when I am traveling the pointer, I should know when I have to complete my traveling. That is, my pointer is now here, and I am going to move here until the 18th byte. That is, starting from 0, it will be on 17th. So whenever I am moving from one location to another location, if it is a U8, someone has to increase. That is, whenever I go to the next location means what? In a UTF-8 or in a U8, it is pretty simple. That is, you are moving 1 byte next. But if it is U32 bit, it is in fact 32 bit, so which is 4 times of this U8. So whenever I want to move from one location to another location to get some useful information, I have to travel 4 bytes. So assume this is a U8, so it is 1 byte, And if I have a number here, then probably I have to travel 32, 4 bytes, not 32, 4 bytes in order to get some useful information. So all these things will be done by a great method that is available in the pointer called as ptr.add I. So when I put an add I on this, what, okay, where is this ptr? Okay, yes, ptr, okay. So let me get this ptr again. Is slice dot. So we will use this, our discovery as star const str as star const 28. So now we have this another ptr. We'll call this as a sptr new. Okay, and the slice, the same slice. We'll use some decent name for this, another ptr. So I'm taking this another ptr, I'm adding I to that, meaning initially it will be 0, so it will remain there, and then it will read the next 8 bit or 1 byte. And what this will give me, this is again an unsafe function, because I'll again explain why this is an unsafe function shortly. So when I'm adding an I to this will give me some value. So what is that value will be? Let us store that somewhere. And this value is a pointer again, star U8. So we are keep on getting pointers, but I want to have the value this pointer is pointing to. So we know that if you apply, let us first put a safe block to make this error to go, sorry, unsafe block to make this error to go. And after I have received this pointer, which is now a star constituent, I am going to deref this. What I mean by that is I am going to use a star to this. Now, when I put a star to this, what is happening is I am getting directly the U8 now. So, when I am not dereferencing this thing, I am getting a pointer. Now, I want to get the value this pointer is pointing to, that is this na, not na, because it requires 3 bytes to make this as na. So there will be some byte here. It is not pointing to the na. It is the first byte of that makes this na. So I am putting a star here that will help me to get the first byte, which is a U8. So I will keep on get this value and I can put that into some vector so that I can use this from UTF-8 that requires a slice of U8. Okay, what I mean is, let us create a values, which is a vector, and the type of that will be vector U8, and it is mutable. And I'll put this value into these values, and now what I'm having is an std vec of U8, and we know how to convert a vector completely into a slice. It's very simple. For example, let this slice again equals ampersand. If I put ampersand vec U8, I mean ampersand slice, values, what I am getting is not a slice, but I am just getting an address to that. But what I need is a slice like ampersand U8. So how to make this vector into a slice is that we can do is we can just use this range operation. We can make this into ampersand U8. This is one way that we can do. But don't worry, you do not do all these things. As we learned from the Clippy, you can pass to this method this vec of U8 that will be coerced into a slice of U8. Now it is giving an error. You just apply the reference operator to this. That will be automatically coerced when you are passing a address to, I mean a reference to a vec of 8 will be coerced directly into a slice. We will discuss on another occasion what is really happening when we are reading more about referencing and dereferencing. Now this way we have the next result, another result, and if we print the same, another slice, we'll print this another slice here. So if I run this, okay, so we have successfully reconstructed a pointer if a length is given to us. I am again insisting on the length for a reason, and we can convert that into a slice back using either as PTR, or you can do this double casting. Convert first the slice to the STR counterpart, and then you convert that into a pointer of U8. And then whenever you are adding a pointer, adding I, in fact what you are doing that you are not adding, you are just promoting this pointer from one location to the next location of that many bytes. For example, if it is U32, then it is 4 bytes. If it is U8, then it is 1 byte. And that is what this size is all about. So it is using an offset method to move to that many bytes whenever you are calling this add method. So don't confuse with this add method with our regular add method. We are not adding any I to this another pointer. Rather, we are pushing this pointer to the next readable location. That's what this add is all about. And we are doing another adventurous thing here, because whenever you are dealing with a pointer, you always get a pointer. So when you dereference a pointer at some point in time, you get the value that what it is pointing to. We can make use of the auto coercion of a ampersand vec of U8 to ampersand U8, I mean ampersand within square bracket U8, which is a slice. That is what will happen to from UTF-8, and then you are getting this, and then you are just printing that. So quickly, so make this particular confusion to go. That is, you have a, assume that you have a vec of 3, 4, 5, 6, 7, 8. Okay, and assume that you are having a function accept vec, for example, and accept vec slice, for example. I can call this accept vec rec by passing this ampersand here. I mean ampersand of vec here. What is this doing? Okay, so here the param is equals ampersand vec of U32, for example, and this is what it is, ampersand vec of U32. And you can also pass this same vec in the same way to another method that is not ampersand vec of U32, but it is rather ampersand U32, which is the slice form of the vector. See this magic, accept vec slice ampersand vec. Say this is getting automatically coerced into ampersand vec is here, it is coerced into ampersand U32. and here it is automatically coerced into ampersand. It's not coercion, it is directly it is being considered as a ampersand vec of u32. So whenever you are dealing with a vector and whenever you are passing a reference to this vector, you always prefer this method. This method is no longer required. In essence, this is what is happening here. So this from UTF-8 ampersand U8 is, you can very well pass just the ampersand of this vec U8. So this is one of the famous errors I used to have even after several years of writing rest. I used to get this error of from Clippy used to give me not an error. Clippy used to give me the suggestion that cargo Clippy, when I run this, why are you passing an ampersand vec of something? It will be automatically coerced into a slice. So it is sufficient you pass the slice to f from UTF-8, so ampersand U8. So this way, if you have something that is part of an array, you need not write one more method. You can very well get the slice of that, and then this method that can accept any slice of U8 in nature. So before I conclude this episode, I want to perform one more experiment where I want to see what is the behavior of a code that drives the pointer beyond the boundary of a slice. So this is an explanation of a scenario where we have a vector of u32. That means when we mean by u32, each of the elements in this vector occupies 4 bytes. So in fact, when you promote a pointer by using the add with an index, it will promote internally 4 bytes per iteration. Okay, so let us see the situation in more detail now. So the blue colored band is a representation of a vector with each of the elements have the number against the indices. So if it is a second index, then the value is 13. And the green colored band is an indication of a slice I am going to get out, or I am going to interest in playing with. So we have to stop using the word carving out, because there is no such concept called as a carving out when it comes from slice. It is part and parcel of the entire vector. So the length of the vector is 9, and there can be some additional capacity which I do not know, and that is not the intent of this exercise. And this is how we used to represent a slice for U32, vector of U32. When you are taking some 3 elements, then we used to denote this as an ampersand of t, where t is U32. And when you are using an S pointer on this vector, it will point to the first byte. Should I have to use this word first byte? Yes, correct. It is first byte. But whenever I am promoting this thing, it will automatically skip that 4 bytes per iteration. So this is pointing to the first byte of this slice, and whenever I promote, this will go like this. So will it just stop here the moment I ask for more than 3, or will it go to 17? Let us see the magic by doing an experiment. Join me in doing this thing, and this will be an opportunity for us to completely do a recap of all the things that we have learned so far. So this is the vector. So let us make this as some park, and create a fresh main method so that we can avoid typing certain things. So let me take this vector representation. Let us ensure that it is a vector of U32 to mimic our scenario. The values are starting from 11 to 19. So 11, 12, 13, 14, 19. And we are going to target a slice from 14, 15 and 16, that is from 3 to 5 of this vector. So that is the same, that is 3 to 6 should give us the slice that what we are interested in. And let us anyway check this, and I'll also check what is the capacity of this vector and the length of the vector. So the length of the vector slice is v slice. We will print the size of the vector. The one in the part function that we can refer for later revision. And what else is required? Let us print the capacity. The capacity for this context should be equal to the length, I believe. The capacity of the vector is vec1 dot capacity. So do we have all the ingredients ready? Ampersand u32, and this v slice is an ampersand slice of u32, and let us check what is the result now. So the length of the vector is 9, the capacity is also 9, 14, 15, 16 is what we are targeting, and the length of the vector slice is 3. Fine. So we have our test scenario recreated, and now we are going to drive the pointer beyond the boundary of a slice. So we will get this method where we are using the slice from raw parts, and we want a pointer to this v slice. So let the slice pointer v slice dot first pointer, and we will use the slice pointer in place of the s pointer, and the length of the slice is the v slice dot length, and this is going to give us what's the error now? Expected u8 but found u32. Yes, because this should be u32. Fine, because the slice pointer is pointing to here u32. This is a u32 constant. First byte of it is a u32, and hence the resultant reconstructed slice also should be ampersand u32, and this should be equal to what we are having as a v slice. So v slice and reconstructed, both of them should be equal. So let us print then the reconstructed here, and this is the original slice. This will be a distraction for us, so we will remove this, that unnecessary printing, and so the reconstructed slice 14, 15, 16 equals what we are originally having. So raw parts is fine. Now I know that the length of this slice is 3. Let me increase this by, instead of using this v slice dot length, let me hard code a random value of some 5. Let's check what happens now. This is the behavior that we want to observe. Wow, it's giving us 14, 15, 16, 17 and 18. So this is a clear indication that even we are playing with the same slice, and when we are asking for more than what this slice has in this length, the system is blindly moving the pointer beyond the boundary of the slice. This is called as a undefined behavior. That's why we are making sure or we are giving an indication to the programmer who is reading this as this is unsafe. And what happens when I provide, now it has reached 18, so let me make this as 6. Reached up to 19. And what happens if I provide beyond the boundary of this array itself? That is, let me put this as 7. And it is giving some 0, and there is no 0 at all in this vector. And if I put this as 8, and again 0, and let me make this as 9, it keeps giving you 0, 0, 0, because we have reached the end of the array, and it is giving you the some random value 0, 0, 0. So this is an undefined behavior. So we need to be very careful about the length of the slice when you are reconstructing this raw parts. So that's why I reiterated many times that why length is very important. Now let us do our for loop of promoting this pointer using the add method on the pointer. Okay, let us do that in a different way now. For 0, sorry, for I in 0 dot dot, we know that it is up to b slice dot length. This is what the normal way in which we used to promote this. So what we will do, we will call the pointer the slice pointer, and then we will invoke this method add, and then we will pass this I, and this is an unsafe operation, and we will put that in an unsafe block, and we will put this value somewhere, and this value will be again a pointer, so we will dereference this, and this value will be a u32 now, and we will let us just print this value here. Dang it. Now, as long as it is within the boundary, the behavior will be a defined behavior. But still, we need to be careful about that. How you run. So it's printing this 14, 15, and 16. And I guess we have the reconstructed here. It's proper to have it here. And let us start worry about the pointer arithmetic now. So we have 14, 15, and 16. And let me give a value of not 3, as we did here 9. We'll give this as 0 dot dot 10 for example. So let's keep on giving us this 9, 10, 0, 0, 0. What will happen if I provide a large value 20? Okay, so 0 is an indication of a kind of a termination of end of slice or end of array. We don't know. So we need to be careful. We are responsible for providing the right length here when we are dealing with the pointers. So this is the completion of this experiment. If you drive or promote the pointer beyond the slice boundary, then it will start point to the array this particular slice belongs to, and when it has reached the end, it will silently not throw you any error. It will keep on giving a value in case if it is a u32. We do not know what will be the situation if it is a i32. So let us quickly make this as an i32 and make this as an i32. Is it the same behavior? Yes. And thank you very much. And the next episodes will be using this lesson to count the pattern in a given character, in a given sentence, or in a given corpus of data. Thank you again.